Next, we're going to take a look at special cases. You learned difference of two squares, sum of two cubes, and difference of two cubes. I also had mentioned perfect square trinomials in previous videos. I'll post the semester 1 videos on Google Classroom so you can go back and look at it, but you can just as easily complete it using case 1 or case 2 methods for trinomials. So I'm not going to go over that again. But let's start with the difference of two squares. And I'm just going to cross off a little typo here. So when you have, keyword, a difference of two squares, we can write it as a plus b and a minus b. So we get a and b by asking ourselves, what can we square to get the first term and what can we square to get the second term? For example, if I have 9x squared minus 25, to find a and b, I need to ask myself, what squared will give me 9x squared? Well, 3 squared would give me the 9, and x squared would give me x squared. So a would be 3x. If I were to ask myself what squared would give me 25, the answer would be 5, making b 5. Now that I've identified my a and b, I can just plug it into my formula. So ax squared minus 25, or 9x squared minus 25 is equivalent to 3x plus 5 times 3x minus 5. Now taking a look at the sum and difference of two cubes. Not a lot of people memorize this in first semester, but I do want to point out something that'll make it a little bit easier. The sum and difference of two cubes are exactly the same other than their signs. Notice how the first parenthesis in both have a and b. The second parentheses in both have a squared, ab, b squared. So when we're adding for the sum of two cubes, we're going to have plus minus plus. And when we're subtracting for the difference of cubes, we're going to have minus plus plus for our signs. Let's start with this example here. I have x cubed plus 27. To identify a and b, I need to ask myself what cubed would give me each term. So to find a, I would ask myself what cubed would give me x cubed. The answer is x. If I were to ask myself what cubed would give me 27, I would say 3, because 3 times 3 is 9 times 3 is 27. Also, if you're ever unsure, just use your calculator to check. As a reminder, if I wanted to see what 3 cubed is, I would plug in my 3. And then for the power, I would use this little caret button here. And then cubed. 3 cubed is 27. So it did in fact work. Alright, now that I have my a and b, I'm just going to plug it in. So because it was the sum, I know it's plus minus plus. So this is going to be equal to plus minus plus. Going to fill that in. So it's AB, so x3. And then here I'm going to put a squared. So x squared is just x squared. Right here I'm going to put a times b. So x times 3 is just a 3x. And then right here, I'm going to put my b squared. So 3 squared is 9. Remember how I said in the past, always check and see if you can factor any further. So when I look here, this is a trinomial, so I have two different cases, remember? Case 1, which is where a is 1, and case 2, which is where a is not 1. So here I have a equals 1 because the leading coefficient is 1. So I just need to see, do any factors of 9 add to give me -3? The factors of 9 are 1 and 9, 3 and 3. And there is no way that can add to give me -3. So this is not factorable, meaning that we have found our final solution. Had this been factorable, I would have had to continue further. All right, next, the difference of two cubes. Remember, you need to ask yourself what cubed would give you the first term, and then what cubed would give you the second term. So what cubed would give me 64x cubed? Well, 4 cubed would give me 64. It's okay if you don't know that. Remember, you can check. So let me see. 4 cubed, yes, really is 64, so that works. And then it's not just 4. This is a 64x cubed, so A would be 4x. B, I need to ask myself what cubed would give me 125. And 5 cubed is what would give me 125, meaning B is 5. Now that I've identified A and B, let's just plug it into our equation. So because this was a difference of 2 cubes, I know it's going to be minus plus plus, so minus plus plus. In the first parentheses, I just put A and B, so it's 4x minus 5. In the second parentheses, the first term is going to be A squared, so 4x being squared. You need to distribute that square to both the 4 and the x. This is using your properties of exponents. So 4 squared is 16. X squared is x squared. The middle term would be A times B. So 4 times 5 is 20x. The last term is B squared, so 25. Okay, factoring by grouping. I did want to show you factoring by grouping where it requires you to pull out a negative, because some people struggle with that. So once again, remember we've already practiced factoring by grouping. I'll post the semester 1 factoring by grouping videos as well if you need extra help. This is just a review. So factoring by grouping, we look at the first 2 terms and the last 2 terms, and we pull out their GCF. The GCF for the first 2 terms is going to be x squared because I pull out the lowest power. If I pull out an x squared, I am left with x plus 7. The last 2 terms, the GCF is 3 because they're both divisible by 3. Now notice how if I were to pull out a positive 3, what would remain is a negative x minus 7. Negative x minus 7 does not look exactly like what's in this first parentheses here. So we would not be able to factor by grouping. However, if I were to pull out a negative 3, so having a negative GCF, that would leave me with a positive 1x plus 7. That's exactly what I want because now what's in parentheses is the exact same, meaning I can pull that out. It's my new GCF. And then in parentheses, I would need to write what remains. Always check if you can factor further. I have a quadratic here. It's a binomial, so I know it's probably going to be one of my special cases if I were to factor it. Because it's squared, I know it's not going to be the cubes. So is this a difference of two squares? Well, this one is, but this is not. If this were x squared minus 4, I would have been able to factor further, but because this is 3, I cannot factor any further, meaning this is my final answer. Once again, I want to remind you that this was just a factoring review. The purpose was for me to go through and remind you of things that we've already learned. If you're still struggling with something like case 2 of factoring trinomials or just the idea of factoring by grouping in general, go back to my previous videos and re-watch them, or find another online resource like Khan Academy. Now that we've done a factoring review, you're going to do a factoring review worksheet, which is included on page 2 of your PDF. So go through and attempt those problems. And I do want to say this, I don't mean to lecture, but on your homework, when you're attempting it, okay, this is what your homework looks like. Please, please, please read the directions and use the method that I tell you to. And also, don't use a math app. I need you to show your work, and I need you to attempt it on your own, because if you don't know how to do this, you are really going to struggle with Chapter 5. This is essential that you know how to factor quadratics. So again, attempt it on your own with the help of your notes. Don't use online resources. If you need to talk with your peers, that's okay, as long as you're having a discussion. Don't just copy it from them. Again, if you do not know how to factor, you are going to have major issues in Chapter 5. So please work with your peers, use your notes, go back and watch videos, and ask me for help when we are in class.